Hey everyone, welcome back. As you know already from the title of this video, today we are tackling the strategy part. So if you watched the last video on singleton pattern, you already know how we do things over here. In that video, we didn't just memorize the pattern. We started with a brute force approach, found the flaws, optimized it, and eventually scaled it to a completely thread safe solution. Finally, in this video too, we are going to follow the exact same structure today. I'm going to give you a problem statement. We'll apply our brute force solution, analyze exactly what's wrong with it, and then step by step fix those issues. By the end of this video, you won't just know the code for strategy pattern, you'll understand the exact necessity that led to its creation in the first place. So, a quick heads up before we start. If you haven't seen my previous video yet, I highly recommend watching it first. It's not strictly mandatory, but yeah, these videos are based on difficulty rating. Watching them in order will help you get the hang of things and how we tackle questions. And it will make today's problem much easier to digest. Also, before starting off with today's video, there are some ground rules that I mentioned in my previous video. We'll be mentioning again over here. First, I'll be coding things in C++. You guys can use any language that you want. The underlying principle and architecture would be same across each and every language. The syntax might be here and there, but the underlying principles will always be the same across any language. Second, in actual real world scenario, your code might have multiple design patterns being used at the same time for a given problem. So just to simplify things, I have scaled this problem down so that we can only focus on one pattern that we are solving for at a time. Also, while coding the solution, you don't have to worry about the underlying logic of the problem. It's just how we want to write classes. All right, let's jump on today's problem. So the problem for you guys would be, let me just copy down the problem for you guys. What we are trying to do is we have to build a payment processing service for an e-commerce system. Right now, the system only supports debit card, credit card, and UPI. So these are all the transactions that it supports. It supports debit card transaction, credit card transaction, and UPI transaction. For anyone who is watching outside of India, UPI transaction you might not be familiar with. You can use any other service like Apple Pay, any net banking service, or whatever you feel like. So for this, you don't have to actually implement the logic for deducting money from each of these transactions, or wire up a payment gateway service like Stripe or Razorpay to this. That logic is abstracted away, and just you have to console out the results. Don't worry about actually wiring up these services. It's just you have to make this payment processing service, build up a class, a function in it, and based on whatever you feel like is a brute force solution, try to go to the solution. Don't think of any fancy patterns, any design patterns that you might think it's working over here. We can use this. If you're confident, go ahead. If you're not confident, I'll highly recommend try to think of the brute force solution, absolute nice solution you can think of. So take some time, pause the video over here, try to think how would you actually code this, and we are back. So hopefully you might have thought of a solution. If you were able to think of a solution, good enough. If you're not able to think of a solution, don't worry, it's fine. When you practice more questions, you'll be able to think how to structure your class. I'll open up my VS Code and we'll try to code up the absolute basic solution. So over here, I have a file called payment service.cpp. I'll just quickly include all my header file. Shoot, my bad. Enter namespace. Then I'll structure my class. Let's call this class as payment service class. In this class, I'll have a public method. For now, let's say it's returning void, just to make things easier. I'll say this is process payment. This will accept a string of payment type, and then it will accept a double amount, how much amount I want to transfer. So if the payment type is equals to, let's say, credit, then what I'll say is just console out for now that, hey, a payment type of credit is being processed. Processing payment. Do a dot dot dot. Then say amount deducted. And this is the amount which was deducted away. Right. And then Finally, we can say payment processed. Right. We can go ahead and say for else if we can add an else if and say for debit too, we can do the same. You just have to change this credit to debit. The process is almost same. And for UPI too, I can go ahead and say that, oh, hey, my payment is processing, amount deducted and payment processed. If it's none of this payment type, we can say we can do an error that wrong or invalid payment type is or invalid payment type. We can simply do this. And that's all. Now in our main application code, we can go ahead and say I want an object of payment service. Let's call it as service for now, which is of type payment service. And for this service, I want to process a payment for credit of amount 100. Similarly, I can go ahead and say I want to do a payment of debit to of amount 50 and then finally of UPI, let's say amount of 1000. This is all good and valid. I'll add just one more to show an error. I'll call it as, let's say for, let it be for crypto. Right. I'll go ahead and say this is of amount 500. We'll go ahead and run this code, see if it's working. It's processing payment amount deducted for all three of them and then finally invalid payment type. We can have indent the answer properly over here, but that's not an issue. So in real world, your services would be completely different. This will not be a console log. A lot of things would be happening over here. There will be checks on your end. If you have a customer, if that customer is valid, if that customer can, actually make a transaction, then you will have call to third-party services like Stripe, Razorpay, etc. Then you might have logging service over here, maybe error handling going on, and many more things can happen in this. So this part, this consoling part is just mimicking how a real world situation would look like. It's never this simple, it's quite complex, but we are not worrying about the actual logic. We are just abstracting away everything and just focusing on how our classes should be structured. If we look at our code, it's pretty basic, right? It's the most absolute brute force solution we can think of. If we want to add new services, we can just go ahead and do else if, and then go. We can add as many services as we want. But what's the issue with this code? Back over here, I'll say what we have done right now is we have created this big ass service. We have called it as payment service. And in this, we are just doing if else and adding on things like the credit, then it's the debit, then UPI. And when we want to add more things in the future, we'll just keep on adding in the else if condition. So you would assume that it's pretty much working all right. And there's no issue in this. But if you might have heard of solid principles, it's violating two of the principles right now. If you don't know about solid principle, don't worry. We'll tackle them one at a time. We'll go through our problem statement, see which of the solid principle it's breaking. Don't worry what it stands for, what it does. In the problem, I'll tell you which of the principle our particular brute force solution is breaking. So coming back to our question, I told you guys it's breaking two of the principles. It's breaking the S and the O. So you might wonder what this S and O refers to. S stands for you should design your class in such a way that it is responsible for only one thing at a time. So this stands for single responsibility. So your class should not be doing a lot of things at a time. It should be responsive. It should be pretty clean and it should be responsible for only one thing. O stands for open close relationship. So, or my bad, it stands for open close principle, which is essentially you should design your class in such a way that it's open for extension and close for modification. What I said is open for extension and close for modification. So let's see how these two are breaking right now. So when we see our payment service over here, it's trying to first decide which of the services I want to use and then trying to actually use that service. So it is trying to do two things right now. First is actually decide which of the service I have to do using the if else condition and then process that request. So this is clear that we are breaking the single responsibility principle over here. Now, when we look at O, it says open for extension and close for modification. Let's say in future a request comes to you and says, I want to add, let's say net banking to this also. Or I want to add, maybe let's say Apple Pay to this. Then what will I do? I'll be using if and else and adding it to the same class. Then definitely I'm modifying the class. And this principle says it should be closed for modification and it should be open for extension only. So definitely this is being broken. Now, actually, let's take a look why each of these is an issue. Let's say for S, if you want to test your individual functionality, then you can't do so. Let's say if I want to just see how my credit transaction are being handled, or what's the issue with credit transaction being failed, I would have to create a payment object for this payment service, then wire up all of these, and then we'll be able to test things out, which is not an ideal situation. Ideally, you should be able to see how my credit transaction are doing, how my debit transaction, and individually handle unit test cases or test cases for each of them. They should not be interdependent. So coming to the open close relationship, what's the issue with this? So if you open your class for modification, there might be a scenario where you're introducing new bugs to your already existing completely fine functionality. What I mean is that you might have tested things out for credit, debit, and UPI thoroughly. Each of these functionality is working absolutely fine. When you modify your class and add these services to your existing functionality, there's a very high possibility that you're introducing some major bugs in your perfectly fine functionality. So instead of this, what we usually do, we extend our existing class, and when existing our class, we add the new functionality in those class. So I'll explain you guys with example. I'll just copy paste this. What we will now try to do, this is a single class. It's acting as a big monolithic service. So to fix this, let's handle the single responsibility. What we'll do, instead of this one big monolithic, I'll just convert this one big class into smaller classes. I'll go ahead and say that, hey, this is my new credit class. Then this is my new debit class. And then this is my new UPI class. So from this one big functionality, I've converted into each individual smaller classes. So what's the benefit of this? The benefit would be if I want to test things individually, I can simply create object of this credit class, create unit test cases, or completely mock the service and check how things are working on only the credit transaction endpoint. Similarly, I can do with this debit and similarly with UPI too. But since these all three classes are essentially doing the same thing, I would need something which is saying, oh, hey, you should have a method in this. You should have the same exact method in this, and you should also have the same exact method in this. For that, I'll introduce interface of, let's call it as iPayment type, and have a method in it called as, let's call that it as process payment. The process payment method handles everything, how a payment process should be done. So this is an interface which will be inherited by this class, which will also be inherited by this class, and which will also be inherited by this class. So now each of these classes are forced to have a method called process payment. Since all of these individual services are essentially doing the same thing, we have ensured that they will at least have this process payment in their body. They can have whatever they want apart from this process payment, but yeah, this process payment is definitely necessary as they are inheriting from a payment type interface. So now what we have done is we have created these individual classes. So they are essentially doing one responsibility at a time. So our first issue, which was we were breaking a single responsibility, is now handled. Coming to open close principle, I told you guys that the class should be open for extension and closed for modification. So whenever we want to introduce a new class, we'll just simply go ahead and say, I want a new class. Let's call it as uh, let's call it as crypto. This will inherit from iPayment type interface, and since it's inheriting from iPayment type interface, it will have this process payment. It can have whatever else it wants, but this will be there. So I'm not changing any of the existing functionality. They're pretty much the same. We have tested this, and there's no issues with this. Earlier, we were changing our one and only payment service, and we could have introduced a lot of bugs in it when we were trying to modify it. But since now it's completely different class, we can be sure of things that we did not change the existing class. So there's no issue with introducing bugs over there. Cool. Now jumping on to the implementation part of this, how to implement this big as monolithic to small microservice like architecture. So jumping on to the implementation part, we would first need to implement an interface. So C++ does not have an interface as keyword by default, but it implements abstract class. So we'll be implementing interface using that abstract class. But other languages like C Sharp, Java, Python, I'm not sure about Python, don't quote me on that. But yeah, C Sharp, Java have this keyword called as interface. You can directly make an interface and be done with the things. Over here, I'll be making the abstract class. It's pretty much same as interface. I'll call it as iPayment type. I'll be like, this is of type public. I need a method in this which anyone who is inheriting has to override. It will accept an amount, and this will be a pure virtual function. I also need to create a destructor for this. This is something very exclusive to C++. You guys don't have to worry about if you're not coding it in C++. But yeah. Anyways, we build this iPayment type interface, then we'll define our classes. We'll just go ahead and do this and call it as credit transaction and be like, this is publicly inheriting an interface of iPayment type. I'll have a method in this called as void process payment. I'll just simply copy it. And I'll be like this, override the base class method. And we'll do exactly the same thing which we did over here. Right. I think that's pretty much it for this credit transaction. Similarly, we can go ahead and say the same thing for debit transactions too. Similarly, I can go ahead and do this for UPI transactions too. And all of them are inheriting from interface iPayment type. So pretty much cool. We can just remove this whenever we want. We can create an object of individual transactions and use those in our code. So if I ever want to process a credit transaction, I'll be like credit transaction. Here is a object for you, credit transaction, which will be creating an object for credit transaction. And I can simply go ahead and say credit transaction dot process payment of 100. Cool. I can simply remove all of this. I can do this similarly for debit too. I'll be like, this is my debit transaction. And similarly, I can go ahead and say, this is my UPI transaction. I made this like this. Yeah, cool. So from that one big messy monolithic code, we structured our code in individual classes such that they are doing a single thing at a time. And the things are open for extension now. We'll quickly run this code and see. We can see payment process for credit, payment process for debit, and then payment process for UPI too. Now, if we look at our problems, we have solved the single responsibility problem. We have solved for open close relationship problem. There's one thing we missed out particularly, which I didn't tell you earlier, but if you could try to think, pause the video here, try to think what's the issue in our code right now, how we can enhance this code, and what could be, a better approach to solving this problem. I'll give you guys a hint. It has something to do with individual processing of payment. It's never this simple. Try to think in a way that a lot of processes are being handled here and it's being repetitively done in each of these transactions. Pause the video here, try to think. So, yeah, coming back to our question. If we look at each of these individual transactions, the transactions are not this simple. As I told you earlier, we would have logs over here, we would have third party calls, we would essentially have an error handling mechanism. We would also have checks on our end, right? We would have multiple of these services that will be there in each of these transactions. So let's say I want to introduce a new transaction called as crypto. I'll be replicating my code again and again. I'll be doing, oh, hey, I have to log things, check our end, then also have to implement error handling mechanism over there, and then finally call the third party service, which will be like a Razorpay or a Stripe. And the only thing different in that would be the parameters. The parameters would be credit, debit, or UPI, or whatever they are expecting. So we have a very big flow over here. I'll show you what we are doing right now, essentially. I'll copy paste these over here. And what we are doing is for each of this, we have this object created. And in each of these objects, we first have checks there, then some logging mechanism, then third party API calls, then error handling, then many other things. So this is being replicated right now for each of the object that we are creating. You get the idea. I mean, this is being created for everything. So instead of this whole mechanism, what we essentially can do is we can be like, we can remove all of this. Let's remove this too for now, just to make things simpler. And I can be like, why not just create this in one place, right? And have an object over here, object which is of type iPayment type, which was actually the interface we were inheriting in each of these transactions, and do something like this. Whenever a particular transaction wants to run all of this logic, we'll send a reference of this credit transaction to this class. So what this class will do, whatever the reference of an object of type iPayment type it's receiving, it will set it as the default strategy of this object. What I mean from this is, suppose this is a C1 object and I'm sending its reference to this class. When I'm sending this C1, essentially this object now points to the same reference to. So this object has now become as C1. So now, whenever I want to run all of this logic, I'll say whatever my default strategy is, whatever my default object is, through it, I'll run all of this logic and do the checks, do the logging, do the third party call, mimicking whatever the reference was sent to me. So using this object, I can run all of this logic. Let's say now debit wants to run all of this logic. What debit will do is, now instead of this C1, debit will send its object, or essentially the reference of its object. Let's call it as D1. This class will set its default object to D1. And then, mimicking this D1, it will run all of this logic. So when all of this logic is run with this object, every service will think that, oh, hey, D1 is the one who is calling us. Actually, it's the object. But since this object is referring to D1, they will think that D1 is the responsible for one calling to them. Now, let's say if you want to change things, and now I want UPI to run all of this logic. Simply, again, I can simply do this. I'll create an object U1, or essentially send the reference of the object U1 to this. This will mimic U1, and then run all of the core logic over here. So every other service will think that U1 is the one responsible for running or executing them. So by doing this, I have ensured that during runtime, I can change whatever strategy I want to use according to my needs. Also, by doing this, I've ensured that I'm not duplicating my logic in every other class that I will be making. I've ensured that I'll create this one class, and this one class will be responsible for running everything in my code. So this class only needs the reference of object, and using that reference of the object, this will run every other services that we need. This strategy looks pretty solid to us. But how do we actually code it? It's the real question. So if you are coding it in C++, we have pointers over here. They are available to use to us. If you're coding it in any other languages like Java, C#, etc., you might have objects. Under the hood, these objects will be acting as pointers only. So you would be able to send these objects and you will be referring to the referential memory. So this is something very exclusive to C++. Others can skip it. If you're creating your pointers something like this is your class. Let's call it as payment service class. And you create a pointer for this. You would be using star for creating the pointer and a new keyword for allocating the memory to it. You would be doing something like this. So when you are creating this pointer using star, you are essentially telling to the compiler that, hey, I have created this pointer manually. You don't have the access to delete this pointer. I'll be the one responsible to deleting this pointer. So whenever you create a pointer like this, you always have to delete that pointer. Otherwise, it stays there till your application shuts down. So it can essentially lead to a dangling pointer situation, which is not good. So instead of this, what we'll be using? We'll be using a unique pointer concept, which handles memory allocation and deletion of this pointer on its own. And instead of new, we'll be using make unique. So these two keywords are will be using instead of star and new. So essentially, when you are creating a unique pointer and storing address of other variable in this pointer, you can essentially cannot use multiple pointers for the same memory. This is valid only for one pointer. If you want to shift to the value to another pointer, you would need to use this keyword, which is called as move. If it's absolutely necessary that you have to make a shared pointer where you can allocate memory to different pointers, you would need to create using shared pointer or make shared. So internally, this has a count variable in it. As soon as the count reaches 0, it deletes that pointer. If you're allocating multiple pointers to the same memory, it will increase the count in it. Just a little background information for this. But yeah, anyone who's not from C++, don't worry about this. Create object, pass that object, you'll be good to do. This was something which was exclusive for C++ users. So now, let's go ahead and code this. We'll see that this is pretty much good. What we need is split the logic or put the logic in this one payment service. Let's call it as payment. Uh, let's call it as payment service only. What I'll do is I'll have this object created using unique pointer of type iPayment type and call it as current strategy. Strategy, right? Now publicly I will expose a method called as set strategy, which will accept a unique pointer of type iPayment type and call it as payment type. Right. Anyone who wants to use this payment service first has to set their strategy. So what this will do is set the default current strategy to whatever the reference of the object they're sending it to this class. Well and good. If you see this error, as I was telling you guys that you can't have multiple pointers pointing to the same memory address. So you need to move this. You would need to move this and then this pointer would be deleted. Let's give another process method which will accept a double of amount and be like, hey, we can do anything over here. We can do first logs over here. We can do some checks over here. We can do error handling over here. Right. And then finally, when we want to call the third party API, we can simply do like this. If we have the current strategy as set to something, sorry, if we don't have current strategy set to anything, just return an error. Cout error, no payment type selected, and simply return this back. Otherwise, if we have a current strategy selected, then I'll be like, whatever the current strategy is, I want to process the payment of this much amount and be done. So by doing so, what we have essentially done is created this base object over here. And whoever wants to use this service now has to set its default object to the reference of object they are sending. And we have exposed this method process, which will do all the things which every other transaction service needed. Like we are checking logs, we are checking on our end if something is invalid. Then we are also handling errors. And then finally, when we have to call the third party service, we are just checking that hey, the current strategy is set to something or not. If it's not sent to anything, we'll just console out there. Oh, hey, there's an error, no payment type is selected. Otherwise, we'll run it. Now, what we'll do is we'll create only the object of this payment service and call it as service, which is of type payment service. And whenever we want to do a transaction, let's say we want to do a credit transaction, we actually don't need to create any object. We'll simply go ahead and say service dot set strategy. I'll create a reference of this class and pass it to you, right? And I simply go and say that process an amount of 100 for credit transaction. It will handle the rest. Similarly, if I want to go ahead and do for debit transaction, I'll like change my current strategy to debit cards. I'll send it a pointer over here and be like, I want it of type debit type transaction. And now I want my service to process. Let's call this as 1000. Then similarly for UPI transaction, I can go ahead and do like this. UPI, this will be UPI transaction and then process an amount of, let's say, 500. So by doing so, first let's run this code. So we can see payment is now processed, and payment is now processed for all three of them. So our code, which was decentralized in different classes, like the code was over here and over here, it's now actually centralized in one place. Everything or anything we want to add will just be adding over here, and the rest of the things remain same. In future, any of new transaction type is included, we'll simply add the class for it and send its reference to this payment service and done. So essentially, this splitting up of our code in a very structured manner, where we were following single responsibility principle and then following open close principle. And then finally, when we came to this payment service, we saw that we can set an object, and then using that object, we can run any of the transaction type we want. So this is all the code that you need for a strategy pattern. You have to make sure that your classes are structured in a way that they follow single responsibility principle and open close responsibility principle. And then you have to create a service which at runtime can change your strategy. What I mean is, over here, if you can see, when I want my transaction to be a type of credit, I just simply can do so. I don't have to create its object, then pass the value, or when I want to shift to a different transaction type, I don't have to create a transaction type of debit and then pass. I can simply on the fly just say, oh, hey, now I want all the transactions to be debit. So whenever a transaction is like debit, I can simply go ahead and do so. So yeah, that's pretty much it. That's the code for strategy pattern. So we first looked at our question and saw that we have to build a payment processing service for our e-commerce system. This has to include a debit card transaction, a credit card transaction, and UPI transaction. We were not worried about the underlying principle of how these transactions work. We were only concerned how each of these classes we have to set up. So we first created a brute force approach where we created a payment service, and in that payment service, using if or else, we were able to handle each of these transactions. What we saw from that, it was breaking two of the principle of solid, which was single responsibility and open close principle. S stands for single responsibility, O stands for open close. So essentially, from a big ass monolithic, what we did was we converted into small microservice type architecture. We introduced this iPayment type interface, and whatever the transaction type we were introducing, we ensured that this iPayment type interface was inherited by those transactions. This ensured that there was at least this process payment which had to be there in each of these transaction type. They can have whatever they want, other than this process payment type, but yeah, this is mandatory. So we were essentially converting this monolithic into single responsibility, small individual classes. And if you wanted to introduce a new class like this crypto class, we can do so. We can say, oh, hey, inherit from this iPayment type interface, and then extend this interface. From that, we saw that, yes, essentially we have converted our code to smaller classes, which were handling things on their own. We had these multiple things which were essentially done by all of these process payment types, which were, like checks, logs, third party API header handling. Since all of this code was used again and again in each of these services, what we thought of doing from this, we converted our code and said that we can create a class, and all of this decentralized logic could be centralized into one place. And whoever wants to use this class can send their reference to this class. This class will set it as its default object and process the whole services using that object only. So by doing this, we were essentially changing our strategy at runtime, and hence our code was also centralized. There you have it. We went from a massive ugly block of if-else statement that would require a completely rewrite every time we had to add a new feature, to a clean scalable architecture using the strategy pattern. If you like this video, hit a thumbs up. Let me know down in the comment section which design pattern you want me to break down next. Until then, keep practicing, and I'll see you in the next one. Happy coding.